Algebra 2, Worksheet 32.2 on the back. Concept 22, I'm going to do all of Concept 22, numbers 13 through 17. Where it asks us, and from the first four, 13 through 16, it says, label each equation to the name of the conic section it describes. And remember, conics, you had parabolas, circles, ellipses, and hyperbolas. The easiest to spot is always the parabola. The parabola is where you're looking for just one square term. 13, I've got two exponents squared, two of them squared here on 15, two of them squared on 16. There we go. There's only one square. The y's are both to the first power. There's my parabola. So that's the easiest one to spot. Now with the rest, they're trying to trick you here, because with the rest of them, what you want is you want the square terms together on the same side. And in all three of these, the square terms are separated. There's one on each side of the equation. So you need to move them all together. So this 3x squared we can keep there. I'm going to move this 3y squared over, which means I'm going to subtract 3y squared. I'm not even going to write the rest. I just want to see these two together. This one's 3x squared, and then I move this minus 3y squared. I'm going to add it to both sides. It makes it positive 3y squared. This 3x squared again, like the other, stays there. This minus 6 moves over, which gives me positive 6y squared. So now I've got all the squares together. That's exactly what I want. Now we start looking at the similarities and differences here. Remember that the hyperbola is the one where you have a subtraction. You have one of them positive, one negative. The only time that happens is right here in number 13. Positive 3, negative 3. There's my hyperbola. The circles are where they're exactly the same number. They both should be the same sign. They might both be positive, might both be negative. But here, positive 3, exactly the same number. That's my circle. The ellipse sometimes is the hardest one to spot. The ellipse is where they have the same sign. They're both positive, both negative, but they have different values. Here we have both of them being positive. 3 and 6 are different numbers, though. They're different values. That means that's our ellipse. For number 17, now we're filling in the blanks. The equation 16y squared minus y squared equals 16 represents A, and then we have to name that conic section, and that's, oh, one typo, that should be an x squared. Oops. Now, the squares, like before, remember the squares we want on the same side, they're already on the same side. One's positive, one's negative. Right off the bat, I know that this is going to be hyperbola. Then it's a matter of getting these other important parts that they're asking for. We have to find the center and the vertices. Remember that the hyperbola had to have a 1 on the right side, and it's kind of 16 now. So what I'm going to do is I'm going to divide everything by 16. I'm going to put that result over here. It's going to be y squared over 1, because the 16s will cancel, minus x squared over 16 equals 1. Now the center, since there's no parentheses, it's just x and y plain by themselves, the center is just at 0, 0, at the origin. The vertices go with the ones that are first on the first variable for the hyperbola. So this y means if I started graphing it, the square root of 1 is just 1. So I'm going to go, since it's y, here's my center, up 1 and down 1 from y. Those two would be my vertices. Now if you're going to keep graphing it, which you don't have to on this problem, but if you're going to keep graphing it, for the x, left and right, the square root of 16 is 4. So I'd have to go left 4 and right 4. And then you draw that box. And then you draw the x through the box. Those are your asymptotes. Then remember that since the y is first, it's vertical, so the parabolas, the two parabolas that make our hyperbola will go there and there. But again, what that tells me is that these 2 points are my vertices. This point is at 0 and 1. This one is at 0 and negative 1. And now I'm done with concept